And it does for many years now. It was really a big surprise for us. And it turns out that we thought that, oh, the point cursor we defined, so where to weave into the JDT, or that might change. We need to adopt that all the time. But as you know, JDT is not changing as fast as you would imagine it could be. So those points were pretty stable. And the hooks that we used in the Equinox runtime to inject our aspect weaving, they are pretty stable too. So they didn't really change. And Tom Watson from the Equinox team, he did a pretty amazing job of keeping that API stable all the time. So we didn't have to change our weaving code at all over time, which was kind of a big problem that we imagined at the beginning. And a nice other benefit from that was it even works if someone is using a patched JDT. So if someone is not using the real JDT that's coming from Eclipse, but maybe a patched version, like you use the object teams tooling that comes with a patched JDT, some kind of modified things. As long as those points where we weave in are not modified, it still works because we do not make any kind of additional assumptions for that. But it is still shooting at a small problem with a big weapon, right? You have this kind of heavyweight tooling, and we had to implement caching for the woven classes. Otherwise, you would screw up your memory at class loading time all the time, so your Eclipse would not kind of consume a gig, but maybe 2 or so. So that was kind of crazy. So we had to add more stuff. So it was causing more work in the end. And another side effect, another bad side effect was that testing our own IDE and testing the SVJ tooling, that really was a nightmare. Because you need to set up a test environment where the test environment is doing the weaving too. So setting up a runtime workspace, a runtime workbench, starting that up, you need to configure that quite carefully to inject the right hooks, do the weaving, and setting that up is really complicated. So it causes a lot of pain, but it works surprisingly well in the end. Then came Groovy Eclipse. Because people said, oh, Groovy is really interested, and you know, the Groovy team, the team joined the Spring team at that time, so we thought, oh, we should do Groovy tooling for Eclipse. So support a new language in Eclipse. What can you do? You can copy JDT again, or you can implement everything from scratch. But oh, there is already a Groovy compiler out there that is written like the Java compiler somehow. So what was the idea? The idea was, hey, let's not waste so much time in changing everything and re-implementing a new compiler and re-implementing everything that Groovy did. Let's try to reuse what the Groovy compiler does. So that's good. How can we do that? Now, can we do that maybe for more languages than just Groovy? Because next time, I don't know, another group might come along. So we thought, OK, let's grab a copy of JDT again. Let's modify that copy and massage the JDT itself to make JDT aware of multiple languages. So we massage JDT so that JDT can invoke other compilers and other infrastructures while it's doing its build, right? Injecting the Groovy compiler in the compiling pipeline of the Eclipse compiler at the right point in time, and map the constructs of the language back to the JDT model. And that was kind of awesome, because now you get a compiler. This compiler can compile Java and it can compile Groovy, can compile both languages at the same time. It can deal with cross-references across those languages. And if you want to inject a new language, like, oh, next time we would like to support Scala or Rust or whatever, yeah, let's just put that in, and that's it, right? Call it at the right point in time and map the constructs back. So it seems like an awesome design for doing Groovy Eclipse. But since this is a hack JDT and a different version of JDT, you, again, cannot run that side by side. So you cannot say you run JDT and you run your hacked version. Otherwise, you would need to kind of completely modify the existing fork of JDT. So we chose to do something like a feature patch. Right? OK, if you install Groovy Eclipse, we replace your JDT that you have in your IDE with our version of JDT, with our kind of patched and hacked and improved version. Good point is, it would still work with the SBJ tooling because that doesn't care about whether it's a real JDT or a patched one. So we did a feature patch, which you can do, right? You can implement a feature patch that adds or modifies stuff of an existing bundle in Eclipse. That's regular stuff, right? Nothing that's forbidden, but you can do that. So we did that. And then we had the feature patch, people can install that, and we found ourselves back in Hell's Kitchen. Because doing JDT feature patches for Eclipse is really a nightmare. It was really a crazy idea. It was a crazy idea because, of course, JDT evolves. And people want to use the latest JDT. So we had to keep up with the latest JDT all the time. So whenever there was a new JDT version, we had to kind of update our fork with the latest JDT changes, plus our changes. Caused a lot of work. Next was, we thought that, oh yeah, calling the Groovy compiler, that's an easy thing to do, right? Calling the existing stuff, but it was not as easy as we thought because the Groovy compiler itself needs to be hacked and patched. Because it's not an error recoverable parser, for example, so it cannot deal with errors like the Eclipse compiler does for Java. So you would not get a nice editor feeling if you would use Groovy Eclipse. If it would just call the existing Groovy compiler, because at the first error, it would just screw up and stop doing anything. Okay, let's hack the Groovy compiler. So we have a hacked JDT, we have a hacked Groovy compiler. We had to maintain both. And then the Groovy compiler was not designed to support multiple versions of the language at the same time. So we ended up, okay, we need to do some more stuff for that. So it turns out to be another real nightmare. And then you had to take care of what version of our hacked JDT can people install into their Eclipse. Is it just random? Like, oh, that guy is using a newer JDT, now he installs Groovy Eclipse, now he gets an older version with all the old JDT bugs inside? Not a good idea. So you like to prevent that. On the other side, some people were coming in and say, hey, guys, can I just install your Groovy Eclipse? And you have a newer JDT version, but I have an old Eclipse version. Can I still do that? Yeah, maybe, on your own risk. So it really caused a lot of trouble. A lot of trouble. So one advice from this work was, and we really tried hard to do that, is to at least, if you want to do that, at least fully automate the process of changing the fork and updating the fork. Right? If you use a fork of JDT and you would like to integrate and merge in a new version of JDT, fully automate that process. Otherwise, it's not going to work. So hacking the JDT, it really kills you over time. So it was a great idea. So in total, this talk is filled up with great ideas that turned out to be really stupid ideas in the end. So don't wonder. Right? So hacking JDT and copying, that was a bad idea. Weaving worked, but didn't make a lot of sense. Feature patching worked, caused a lot of pain. Copying JDT worked, caused a lot of pain. And some languages, they already came with compilers and parsers and linters. And you might have heard that in the keynote as well. So they come up with implemented in different languages, JavaScript and Go and so on. So the question for us was also to why do we have to re-implement everything in Java just to get it into Eclipse? And that's really the hard part of getting the tooling for those kind of languages, SBJ, Groovy, and more into Eclipse. We really need to implement everything. So what to do instead? As some people mentioned, we're also moving into the direction of using external processes for doing the language tooling, the language server protocol and the Visual Studio Code style of architecture, and use that inside of Eclipse for new stuff that we are doing. That seems to be a great solution, and I guess you've seen, or maybe you've seen, if the demo would have worked in the keynote, that this is kind of an awesome approach and works nicely, but it is not without its own challenges. Because you still need a recoverable parser in the language tooling that you would like to use, right? Otherwise, your editing feeling would be really bad. The language server protocol, that's nice, but it has its own limitations. So if you want to go beyond that, you need to write your own extensions again that are specific for clients, specific for servers. You get JSON overhead, and you get the band playing in the other room. OK, let's move on. Let's do Spring tooling for Eclipse. Cool. Let's do some really cool Spring tooling. So what do we want to do for Spring in Eclipse? We wanted to teach Eclipse to understand your Spring app and to really know what are you doing with Spring. Dependency injection, using abstractions, and all those kind of things. And help you with that, right? Give you content assist. And in the old days, it was heavily filled up with Spring XML stuff. Right? You would configure XML files for configuring a dependency injection and plugging together your application. And working with XML, you do a lot of typos and put in a class name that's not the right class name. And you reference beans, and you would like to get refactorings for those bean names. You would like to get validations for those, and getting the right class names and errors, and all those kind of nice things. So the IDE needs to understand what is Spring all about, and what does it mean to configure a Spring application. So how can we do that? So the first idea, of course, is to parse the code, right, and analyze the code. So take a look at the code that you wrote, and take a look at what's inside those XML files, what's inside the Java files, for example, with annotations. Today, everybody's using annotations in Java config for Spring. What are the annotations, and what are the annotations about? What does it mean? What does the auto-wired annotation mean? And where's another being defined? And so on. And you could build up this model. And we kind of, in the very early days, we tried that, but it turns out that you start re-implementing huge parts of the logic of the Spring framework itself. Like, how does Spring do the wiring between beans? How does Spring create a bean if there's just a factory? What type is that bean of? What about additional libraries that people wrote for Spring using additional namespaces, additional factories, additional Spring features that people added in additional third-party libraries? Do we now have to kind of build an extension for the IDE to support that and make it understand those libraries too, and re-implement and duplicate kind of the Spring framework logic itself over time and try to adapt that to new versions? That seemed like a really, really stupid decision to do all that, because on the other side of the fence there were the other guys sitting there implementing the Spring framework for us, right? Same team. So why should we do the same work twice? So we thought, hey, let's reuse Spring itself to do that. So let's use Spring and tell Spring, hey, Spring, please take a look at the project for me and tell me what's inside and how would you deal with that project. As if you would start up the application. Because usually Spring starts up the application at runtime, and it wires everything together, and then you basically know everything, right? You know exactly what Spring does. So we should try to do that. Reuse Spring as it is. Awesome, awesome idea. Cool. It would adapt to new versions of Spring automatically, so the IDE wouldn't need to change. Just you use a new version of Spring, and it does the new stuff. So that's cool. It's really very exact, right? Because you do not make any mistakes of re-implementing the logic. It's really doing exactly what Spring would do. Of course, you need to take care that it doesn't really fire up the application and things like that. But it seems to be OK and would even work out of the box for extensions. So that all sounds great. But Spring is designed to work on applications and not on source code. Not even on class files. It's designed to run on a JVM and you start up the application. So Spring is built for you load a class. You do reflection on the classes, take a look at the class path maybe of the project, do reflection on that, load specific classes, load specific files, you instantiate classes, you instantiate instances of those objects. So you're dealing with the app that's running as class objects inside of the JVM. which is something totally different than the IDE does. The IDE deals with text files and creating a meta model out of those text files and compiling those text files. So we built a bridge into that. And we built a bridge saying, hey, Spring, if we fire this project over to you, then use the project as it is, right? And really load the classes from the project, because classes are always compiled in the IDE, so that's great. So reuse the real stuff and kind of start up the app a little bit and stop before really objects gets instantiated. So that was the hack that we did. And the hack is sort of nice because you can reuse Spring as it is, right? It starts up the app just a little bit, but you start to load classes from the project into the JVM of the IDE, right? Because you're running the IDE, you're running Spring inside of the IDE, and those Spring libraries are loading classes from the project now, so you're starting to kind of pollute your IDE with classes from your project, which is okay, maybe, but not really nice, and you need a lot of hackery. How does it look like? Let me illustrate that. So you have the IDE, and Spring IDE, I've just simplified that. That's IDE.core, right? That's the IDE bundle for Spring IDE, and that is using a bundle Spring Beans and Spring Context from Spring 4.5, so that is using that stuff to call the Spring API, right? It's really calling the Spring API and feeding the Spring API with the right information, calling the Spring API and getting back the information about, oh, that's the bean model, and those beans are created, and those bean informations are being wired together, and all those kind of things. Really nice, really nice. But it needs to use the project. So on the other side, you have the project. The project consists of class files, and it usually also comes with its own Spring libraries, right? So you package up those Spring libraries 4.3 into your IDE as OSGi bundles. They're used inside the IDE, and on the other side, you have the class files of your project. So that's okay, maybe with different versions and additional libraries. Okay, so what do we do to get a bridge between that? So we implement a class loader, so we create a specific class loader for that, and that class loader can load all the classes from the project on demand. So that way you can just load all the class objects and create class objects of the project inside of the VM of the IDE. But in that case, you would get a clash. You would get a clash because the class loader would load the Spring libraries from the project, which are then not the same class objects that you use in the IDE. So you could not just call them. The types are not compatible. So we made this class loader. We gave it a parent class loader, and the parent class loader of that one is the one for loading the OSGi bundles of our Spring framework that we ship with the IDE. So that's great. Core can still use our Spring Bean stuff, and that's being used by the class loader because parent first loading instead of Spring Beans of the project. So that looks like a really brilliant idea because you can use that stuff. Spring can load everything from the project. Everything is fine. And that's actually exactly how it works at the moment. If you use Spring IDE and use this stuff, it's exactly the way. And the only reason why it works is because the Spring guys doing the Spring libraries, they really take care of making them backwards compatible. So if you're using a newer version, if you use Spring 4.3, in this case in the IDE, and the project is using an older version, they really try hard to be backwards compatible. So that's good. The other way around, it's more complicated, because, as you could imagine from this picture, it's not right anymore. Because during this parent relationship, that changes, right? The new Spring 5 bundles, they go away. They're not visible anymore to anybody, because everything that's inside is being loaded from the other ones. And now, you come into these interesting situations where some people start using newer versions of Spring inside the projects, and maybe snapshot versions, and versions of Spring Boot that is using a specific version of Spring, and stuff like that. And you now mix up with an older version of Spring. You can imagine it. Just by looking at the picture, there will be the day that someone comes back to you with an exception telling you, hey, this method is not there, because some code over here is calling a method that's no longer in the old Spring version. So you really need to kind of update your IDE with newer Spring versions and so on. And to really make this work, you would need to ship a new IDE version with every new snapshot version of Spring, which would be insane. So it's really, it's kind of a strange solution to this problem. So in the end, to me, after dealing with all these issues, and actually people reporting about those incompatibilities all the time, it's really a bad idea to do that this way, I think, today. Because it's not only because you load the code into the JVM, you pollute the space, you run static initializers maybe of the classes, so some strange stuff might happen inside of your IDE that really belongs to the project, and it fills up memory with classes and so on. But really, the version mismatch that could happen is really bad. Because the only way to solve that mismatch is to tell those people, yeah, please disable the tooling and wait for the next version. There's no easy workaround for that. You can just tell people, update that to that version, update that to that version. The only way would be, yeah, please use the same Spring version in your project than we use in the IDE, which is stupid. Nobody would do that, right? Totally stupid. So it's really, but the hardest problem is, I think, there are no workarounds. We cannot tell our users saying, oh yeah, do X and Y and press this button, everything's go away. The solution is, yeah, disable the tooling that builds the Spring model, so you don't get any features out of that anymore, and continue. Maybe in a new version we will change it, or we will update to a new version of Spring, or a new version of Spring is not compatible with the old version of Spring anymore because they removed deprecated methods, and then you end up in the same situation. So yeah, maybe if you still use Spring 2.5, please continue to use STS 2.7, which is built on Eclipse 3.5 or whatever. Really strange, really strange. Okay, instead, do code analysis, or go back to your first attempt, maybe. Or what we are trying to do now for the next version of the Spring Tool Suite, that's what we are working on at the moment for the next major version, to separate things, right? To have a separate process, maybe even use the language server protocol to let the processes talk to each other and build the Spring tooling into a separate process that has its own Spring versions that are just coming out of the project instead of the IDE, and have the protocol to let those guys talk to each other. I think that's the only feasible solution to do that. Okay. Another thing is, another interesting kind of a problem that we came across is we used Spring in the IDE as OSGi bundles, and that kills you. Never do that, right? It kills you. It kills you because Spring bundles, they have hundreds of dependencies, and they have thousands of package use constraints. And if you have bundles with thousands and many package use constraints in your IDE, you will get this. Someone's writing you, hey, I just did an update from minor version X to minor version Y, and now I'm getting this. And you don't need to read that. The interesting part of that is here, it's a package use constraint violation. So somehow, the runtime decided that a JavaX package is being visible to a Spring IDE bundle via two paths because the wiring of the package use constraint on this system package, or JavaX package, is being done differently with a new version and third-party libraries and stuff like that. So it's not solvable anymore, this problem. And if you come across this problem and someone has this problem, the only solution that is, OK, please go with a reinstall of your IDE, which is not the solution you want to tell people, right? OK. And then we thought, OK, let's do some cloud IDEs. And the next thing will be cloud IDEs. Yeah, forget about the desktop stuff. Let's do some cloud. And now we cannot build a cloud IDE on our own. Let's at least build new UIs that we build. Let's build them with web technologies, right? So that we build them once. We can reuse them in Eclipse, and we build them for the cloud. And then reusing web components and web UIs inside of Eclipse is really hard. And we thought, oh, this is an easy thing, right? Yeah, use the browser bridge and everything will be awesome. But getting that to work on 3 different platforms, like Windows, Mac, and Linux, it's impossible. Doesn't work. So we thought about, using the embedded browser. That was a nice idea. Interestingly works on Apple. On Windows, you have to set up specific switches, and on Linux, you have to find out which GDK version supported and which Firefox libraries are on the path and things like that. It's horrible. It's really horrible. Forget about that. Never do it. Then we thought, oh yeah, we use JavaFX. Because there's Tom Schindler, we did the great JavaFX integration into Eclipse, and JavaFX comes with a web browser widget. Hey, that's an awesome idea. Let's use that. It's using WebKit under the hood. And it's a strange, and it's working. We really got it to work, right? It looks nice. It even renders nicely on Retina displays and things like that. But you end up with a UI that looks totally different than the rest of the API, than the rest of the UI, right? Scroll bars look different and behave different, and it's sluggish sometimes. It's really, forget about that. So we end up doing something else. Oh, and by the way, one day you find out it kills your battery life. Right? So someone say, hey, guys, since your new version, it's killing my battery. They say, what? Why is the new Spring Tool Suite killing your battery? Because at startup, we kind of show the dashboard. And the dashboard is the HTML5 stuff, and that renders with JavaFX. And if JavaFX renders web stuff, it always uses the high-performance GPU. It cannot switch back to the low-power one. So it kills your battery. So forget about that. Don't do it. Build SWT UIs in Eclipse and do web UIs on the web. But don't do a mixture of all those things. And then we had the final idea that really killed us in many situations. So we thought, OK, we had a lot of trouble in the past, but now let's get really into more trouble. We thought, we came into a situation where we had to ship a new version and kind of enable and disable certain features in the future for the big product presentation. So, yeah, that's easy, right? We build on kind of a feature flag, a switch, and we call a remote site, so we download kind of a remote property, and based on the remote property, we decide, oh, do X or do Y, and the remote property is on our server, so that's easy. Easy solution, right? The usual thing you would do to remotely control your installation. Say, yeah, on the server, we switch to the flag, and then it's done. Yeah, it's awesome. So we implemented that. Kind of one class, 20 lines, getting some kind of is blah, blah, blah enabled, and is blah, blah, blah enabled, and is this and that enabled. And then we started to use that. And that's OK. That works nicely. That works nicely for everybody in the team. And that works maybe nicely for everybody here. But you start to sneak in network access across your installation. Because there might be a path, a call path through your app that is using the network access down the line somewhere. Because it reads the property, and the property is read the first time it's used over the network. And it's blocking, of course, because it waits for the server to answer. And then it tells you, yeah, it's enabled. Right? So if you're in a proxy environment, if you're in a sluggish network, you start up blocking the UI thread suddenly for people, right? It's just blocked, and it hangs. And blocking the UI on the main thread is really the worst thing you can do in Eclipse, because people can't do anything anymore. Just because we thought, hey, let's do some kind of remote flag and sneak that in. So you really need to be very, very careful when you do network access, and always do that in separate threads, and have some kind of reaction of the UI to that, kind of a default behavior. And then if an answer from the network comes back, then notify the UI or notify someone or whatever to react to this and kind of enable this feature. Otherwise, you end up in these kind of blocked UI situations, and that's really, really annoying. Okay, so running out of time, but that was the ride through my lessons learned. I hope you enjoyed them. If you have questions, come back afterwards. Happy to answer. I hope you still have the faith of downloading the tooling and use it. If you want to do Spring development, even though you know all the strange and crazy ideas now that we did over the years. But I hope you can benefit from that. Yeah, that's a question.
I understand the issue of having Spring bundles in IDE.
Yeah.
Different version from the one used by the
Yeah.
plugins. But why did you need the Spring bundles in the IDE in the first place?
Because the question is, why do we need the Spring bundles in the IDE itself? Because the IDE is using the API of Spring to do something. So we need kind of create an object of a Spring type and call that. And use the API and call the real thing. And if you have that inside of a separate class, though, you could do that, but you would need to use reflection all over the place to do that. And we instantiate Spring, and then we kind of inject a specific environment, so specific subtypes of Spring types into that to start up the Spring of just a little bit and not fully. And to do all that, the only way to do that is to use the Spring library together with your code. Otherwise, you would kind of do meta-programming all the time, which is not really possible in that situation. It would be really hard. Yeah, that's the reason. Okay, more questions. I'm around today, tomorrow. Feel free. Enjoy the band.